So that was all ionic compounds. Now let's look at our other class of compounds, covalent compounds. So in ionic compounds, we had the transfer of electrons. In covalent compounds or molecular compounds, covalent or molecular, that's the two words you may see used to describe these compounds. We don't have the transfer of electrons. Instead, we have the sharing of electrons. And so usually the difference here between an ionic compound where we had a metal and a non-metal, something from the left and the right side of the periodic table, now we have two or more non-metals, so all non-metals. So binary molecular compounds are compounds that consist of exactly two non-metal elements. So hydrogen and oxygen. So an important note, so even though hydrogen is shown on the left most times, so hydrogen is a non-metal. So hydrogen is a non-metal. Carbon, oxygen, two nonmetals, nitrogen, oxygen, two nonmetals. So these molecules are formed through covalent bonds where there is sharing of electrons rather than the transfer of electrons. So they share electrons such that each atom involved is able to obtain an octet of electrons, or is able to obtain an octet or 8 valence electrons. When naming most covalent compounds, so we name the rules are different. So when you're asked to name a compound going forward, you'll first have to decide whether it's ionic or covalent, because that's an important step in deciding how to name it, because the naming rules are different for covalent compounds. So when naming most covalent compounds, prefixes, and you should know these prefixes, are used to indicate the number of atoms of each element in a molecule. So we never used prefixes to tell how many atoms were in an ionic compound, so let's not start that now. So never use prefixes for ionic compounds. But the prefixes are, if there's one of something, mono, di for 2, tri for 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. So you should know these prefixes. So like we said, we use prefixes to tell us how many of each type of atom are present. Now the only time we don't use a prefix is if the first element, so the first element in the compound, there's just one of that element. So well, a better example is, that's more familiar, CO2. So we don't call this monocarbon dioxide, it's just carbon dioxide. So if the first element, there's just one of that type of element or atom, we exclude the prefix mono. But this is carbon dioxide. Here we have dinitrogens, so 2 nitrogens and 1 oxygen atom, so monoxide. So and I think we have a slide coming up, should be, yes. So we add the ending I to the second element. So dinitrogen monoxide, nitrogen dioxide, dichlorine heptoxide, and there are some other rules we'll discuss. Well, we'll just wait. Tetraphosphorus hexoxide. So that's how we name covalent compounds. So the name of the element farther to the left in the periodic table, closest to the nonmetals, is usually written first. I don't think this rule is going to be too important for us, but if you were wondering which one usually comes first. If both elements are in the same group, the one closer to the bottom is named first. Yeah, again, not too important. The name of the second element is given an "ide" ending. And when we talk about electronegativity, this sentence may make a little bit more sense. Usually the least electronegative element is written first, but for now, this is not too important to our discussion. So better, so the prefix mono is never used with the first element. We leave out the prefix mono in front of the first atom in the formula, but include it in front of the second atom. So this is carbon monoxide. This is carbon dioxide, sulfur trioxide. And another rule I was hinting at, so when the prefix ends in A or O and the name of the second element begins with a vowel, the A or O of the prefix is often dropped. So let's kind of go back. So here we would have had dichlorine heptaoxide, but because it ends in an A and the name of the element begins with a vowel, we don't say heptaoxide, we just say heptoxide. So then take a moment to see if you can name these covalent molecules. Then come back. Okay, so then this one would be dinitrogen, and notice we don't add "ide" to the first one. So dinitrogen tetroxide. So it would have been tetraoxide, but since it's A and O, just tetroxide. Phosphorus trichloride. I'll try to write a little neater. Chloride. And then dichlorine heptoxide. And then nitrogen dioxide. Okay, so I want you to solve or name these two compounds. So pause the video, this is important, pause the video, then come back and make sure that you, well, pause the video, name it, make sure, come back, make sure you named it correctly, or these compounds correctly. So the first thing I said was when you name these compounds, or named any compound, you have to decide whether it's ionic or covalent. So the naming rules are different. So this is ionic, so calcium and chlorine. This is covalent. So the name of this would be calcium chloride. Notice no prefixes are used. And then for this one, this is covalent, so we do use prefixes. So this will be carbon tetrachloride. So before naming any compound, make sure that you identify whether it's ionic or covalent, because that's going to determine the naming rules that you use. Some more practice, pause the video, go through those, as well as these ones. So here was write the formula, given a name, and then some more practice with given the name, write, or given the formula, write the name. Yeah, so, okay, so given the name, write the formula, and then given the formula, write the name. And then just to point out that some have common names. So for example, water, So McDonald's uses dihydrogen monoxide in both soft drinks and floor cleaner. I'm not loving it. So this would be the name for dihydrogen, or for water, dihydrogen monoxide, but we don't go around talking like that in most cases. Or if dihydrogen monoxide can rust these pipes, just imagine what it's doing to your insides. But if you want to impress your friends, of course, feel free to use the more technical name for it. But water is H2O2. Water is H2O. Hydrogen peroxide is H2O2. And then ammonia, so this is another common one, so NH3. So NH3 ammonia. So you don't need to memorize this list necessarily, but just be aware that some covalent molecules or compounds have common names, and so that's why they may not follow the rules that we've discussed exactly.